Hello, I'm Jiwan, and in this talk, I will present a framework for removing foreground occlusion in both sparse and dense live field images. In a live field, the occluded objects can be seen in other views. Using this information, live field de-occlusion task aims to reconstruct an occlusion-free center view image. There is mainly two types of live field image. In a sparse live field, which is collected by the camera array, most of the occluded objects can be seen in other views. It is useful for live field de-occlusion, but due to its inconvenience, collecting sparse live field is hard. On the other hand, the dense live field is collected by the micro-lens-based portable camera. Thus, it is relatively easy to collect and practical to apply in various real-world applications. However, since most of the occluded objects are hardly seen in any views, existing methods does not properly work in dense live field images. So, we aim to design a framework that works on both live field datasets. There is two scenarios to fill the occluded regions. If the occluded regions are visible in other views, information from the live field should be used. If not, the context information should be used. Since both scenarios require different solutions, we explicitly divide the model and connect them. By dividing the model into specialized parts, the development and analysis becomes easier and additional applications becomes possible. This is our whole model architecture. Each specialized part extracts features from input live field, defines the occlusion, and fills the occluded regions with rich information from live field and context. We fuse the extracted live field features and inpainted features with simple one-by-one convolution, which outperforms other complicated fusion methods. We use the mask embedding approach for the supervised learning. This is sparse live field images, and our method can reconstruct clear and correct outputs. This is dense live field images, and existing methods shows artifacts from occlusions. But our method clearly removes the occlusion without artifacts. On various datasets, our method shows better metric in both live field images. In ablation study, we test various fusion methods and enlarged de-occlusion. Even with the large number of parameters, de-occlusion does not show better results, and our one-by-one convolution outperforms other more complicated fusion methods. Different from existing methods, by explicitly defining the occlusion mask, various applications are possible. First, like a ground, unwanted objects are considered as a foreground occlusion and removed. We can prevent this by simply editing the occlusion mask by the user definition. Second, in various real-world situations, occlusions may not place in the foreground, but intermediate depth plane. Contrary to the existing methods, we can remove the occlusion placed in arbitrary depth plane without affecting other objects by the simple mask manipulation with live field reparameterization. Thank you for listening our talk.